Okay, so we're ready with the session 5 of the motion in a straight line, wherein we are going to learn about the concept of relative velocity. So here we have a object which are in motion, and inside that object also other things are in motion, right? So motion is a relative item. So here a person is standing on the ground. You can see over here this fellow. It is considered as a reference frame A, and the other reference frame is B, which is attached to the train which is in motion. Now suppose inside a train another object, say fly, is moving either in forward direction or in the same direction as the train or in the opposite direction. Then the interesting aspect is that whoever is sitting inside the train, for that the motion of the fly is a slow motion, in whether it is in forward or it is in the reverse direction. But for the person who is standing outside on the ground, for that the speed of the fly movement will be very significantly large. It depends on what is the speed at which the train is moving. So let's try to understand this concept. First, let's see the animation. In first animation, the fly is moving inside the train and the train itself is moving. So first reference frame is A, which is stationary. Second reference frame is B, which is attached to the train. So with respect to train, whatever is in motion, that will be observed from reference from B. And the point P is the object which is moving inside the train, right? So let's see the animation. See the fly moving in a forward direction inside the train. Of course, whatever you see on the screen is from the point of view of the person who is on the ground. We are not inside the train, so we will not be able to see that effect. Let's see the reverse movement. See, the fly is moving in the reverse direction. One more. Yeah. So this way, what we see is the concept of relative velocity. We would like to study what is the relative speed between point A and B, point B and point the object which is moving, and so on and so forth. So let's consider the first reference frame is the reference frame A. We call it YA. And let us say another reference frame is at O dash, which is moving with respect to say train. It is attached to train. So when train moves, it is also moved. But whoever is sitting inside the train, he is stationary, right? Now this is a point P, which is the object which is moving inside a train. For our case, we have taken example of a fly, right? So suppose this is the train and this is ground, right? So what is the distance? The position, this distance is XDA, distance between D and A. This is the distance between point P from B, and this is going to be the distance of point P from A, right? So what do we see? Naturally, at any instant T, we have captured this photograph and this is the situation in front of you. So what we can see over here is that XPA is nothing but XPB plus XBA. This is the position. If we differentiate with respect to time, differentiating with respect to time, dx by dt is nothing but the velocity. So we get d by dt of xpa is equal to d by dt of xpb plus d by dt of xba. Now this is nothing but velocity of point A with velocity of p with respect to A. This is velocity of point P with respect to B, and this is velocity of B with respect to A. Or in other words, if we simplify, we get velocity of B with respect to A is nothing but velocity of P with respect to A minus velocity of point P with respect to B, right? So this is how, by observing the relative velocity, we can study the different aspects. Let's say this is equation number 1, right? So here VPA is velocity of the particle P with respect to the reference frame A, and VPB is velocity of point P with respect to point B. And what is VBA? It is nothing but the relative velocity of B with respect to A point, right? So it is interesting to find the relative velocity, and there are many practical examples in which this is going to be used, right? Now the situation can be slightly different. In the same diagram, suppose P is fixed on ground and A and B are moving with velocities, right? So we already have the equation that VBA is equal to VPA minus VPB. Now, as the P point is on ground, we can use suffix G, VGA minus VGB, right? And this I can say VGA is nothing but minus VAG, and this is minus of minus VBG, right? So this is nothing but VBG minus VAG, or it is VB minus VA. So all this, the velocity of B with respect to ground minus velocity of A with respect to ground. So simply, obviously this is very common. The velocity of B with respect to A is equal to velocity of B minus velocity of A when they are all with respect to common reference, that is ground. Right? So this is the relative velocity to be used when they are viewed from a common reference point, right? So this is the concept of relative velocity. Now the concept of relative displacement. So relative displacement is a concept wherein we assume that two objects are in motion. Say the reference frame is common, and this is object A. So at t is equal to 0, this object is at this point, and the distance is, let's say, x AO. This is of course O point, and it is moving with certain velocity, say VA. And the point B is over here at the starting of the study, that is, t is equal to 0. It is at the distance XBO and moving in the same direction with the velocity VB, right? So this is at t is equal to 0, we can say at starting. Now what is going to happen? This V and VB both are going to carry their motion in this direction, positive x direction. This is the direction x now, right? So at any time t, what is going to happen? The distance has changed from O. The A is also moved further, right? So the distance of X A, that is A point, was from O distance is the original distance plus the further distance traveled. Now distance traveled is nothing but the velocity into time. So this is going to be the new distance of point A from the reference or O point. And similarly XB is going to be XBO plus velocity of B, and time is same. For same time we are observing this, right? Let me say this is equation small a, this is equation small b, right? So with this, what do we know? That the difference at any instant, the displacement of particle B with respect to particle A, बोलते हैं displacement of B with respect to A will be what? Obviously XB minus XA. So it is nothing but XBO. Yes, equation B means we will have to subtract equation A from equation B. So it is XBO minus XAO into, plus VB minus VA into time, right? So this is the formula which is going to be very useful in calculating relative distance between two objects, right? And so that means this A was moving in this direction, B was at different location and started moving in the same direction. So then this is with velocity VA, this is velocity with VB. So now what is going to be the case? First, if VA is equal to VB, then whatever is the distance between them, whatever is this distance, this is nothing but XBO minus XAO. This was the distance, original distance. This is O point. So if first case, if this is the situation, then this distance between them is going to remain fixed, and that is going to be equal to XB minus XA. So at any time t, the distance between these two is same, which is equal to initial distance, right? Now if VB is greater than VA, VB was already ahead in the direction of motion, and if its speed is larger, then the distance is going to keep on increasing, right? So this XB minus XA will keep on increasing, is it not? So it will go further away, and when the situation is when velocity of A is greater than velocity of B, so B is the vehicle or a particle which was behind the particle B in the motion, and now it is going to, after obviously at some point, so initially at t is equal to 0, A is behind B. At some time t, A and B are at same place, same position, and at any time t dash, which is greater than this t, A will be ahead of B, right? So depending on different situation, we'll have the relative, you can say, position or displacement of point B with respect to point A. So in one direction only we are discussing this motion, right? So in next session through example, we are going to study this same concept, right? Let's see the revision of what we have done today. Today we have introduced the concept of relative velocity. We have seen if the object is in motion inside another object, then there is going to be relative velocity, and this relative velocity concept is explained with the help of the formula over here. So with if a particle is available with certain movement or some velocity, then also we can find out relative velocity. If the particle is stationary or fixed on ground, then also the relative velocity we can find out, and relative displacement also we can find out in this manner, right? So these are the three cases, and we'll have examples based on these three cases and relative velocity in our subsequent sections, right? So that's all from my side in this session. Thank you.